Hey everyone, welcome back to the YouTube channel Devotion of Knowledge. Today we are back again with another Leetcode problem of the day, and we are going to understand the question right from scratch, and we are also going to understand the code as well of the problem. So let us directly move towards the understanding of the question. Okay, so here is the question, and question is minimum time to repair cars. Okay, so let us understand the question first. You are given an integer array. You are given an integer array ranks representing the ranks of some mechanics. Rank I is the rank of ith mechanic. A mechanic with a rank R can repair n cars in R cross n square minutes. This is the important statement. You are also given an integer cars representing the total number of cars waiting in the garage to be repaired. Right? Return the minimum. This is the important statement. Return the minimum time taken. Return the minimum time taken to repair all the cars. Sorry. Now here is the important note. All the mechanics can repair cars simultaneously. Okay. I know the question is not making much sense to you right now, but let us understand the test case given so that we can have some better idea. Let me erase this stuff. Okay. So test case is given with ranks. Ranks are given 4, 2, 3, and 1. These are the ranks of each mechanic that we are given. And total of 10 cars are supposed to be repaired. Okay. Okay. The first mechanic will repair 2 cars. Okay. Let us assume that first mechanic is given 2 cars to be repaired. We are assuming right now first mechanic is given 2 cars to be repaired. Then what was the time taken for that mechanic to repair the cars? It was R cross n square. Now R is 4 and 2 cars are given to him. So 2's square, which is equal to 4. So total of 16 minutes will be required for this mechanic to repair the car. Similarly, second mechanic is also given 2 cars. Okay. So time required for second mechanic will be 2 cross 2 cars are given. 2 square 4 is equal to 8 minutes. As you can see, 8 minutes, 16 minutes. Similarly, third mechanic is also given 2 cars. So 2's square equal to 4 and 4 into 3, 12. So third mechanic will be taking 12 minutes. And similarly, fourth mechanic is given 4 cars to be repaired and 4 square is equal to 16 and 16 into 1 is also equal to 16. So see, it was written in the question that all the mechanics can start simultaneously repairing the cars. So what is the maximum time required to repair all the given cars? It is 16. So we have to return 16 in the answer. I hope I'm making some sense to you right now because the question was somewhat tricky to understand, but now I think it's understandable. Now here simultaneously this test case 5, 1, and 8, and cars are 6 to be returned. Okay, so let us understand this test case as well. Let me again remove the stuff that we have written right now. This is the test case. 5, 1, 8 are the ranks, and 6 cars are to be repaired. First mechanic will repair 1 car. Okay, so 1 square equal to 1 into 5. So this mechanic will require 5 minutes of time. Okay, no worries. Now, second mechanic will be given 4 cars. So 4 square equal to 16 into 1. Second mechanic will be requiring 16 minutes. And third mechanic will repair only 1 car. So 1 square equal to 1 into 8, 8 minutes. So as you can say, all of them can start simultaneously, but the maximum time required to repair all or one mechanic is 16. So we have to return 16 as the output. So I think question is clear to you guys. Let us go through the constraints once. Now, okay, let us apply brute force here. Let us apply brute force. I will be giving you X minutes, and you have to find that how many cars can you assemble in X minutes. Okay, so X minutes if I give you, then what is the maximum time complexity? Maximum time complexity if we apply brute force, because I give you X minutes and you go for each and every at each and every mechanic, make sure that can I make this car in X minutes? How many cars you can know, because cars equal to R cross N square, and I have given you this as X, so you can definitely find out N square. So means you can definitely find out N, and at last we can make sure if N is greater than equal to cars, then yes, this X time was sufficient for me. So in worst case, how much this X can go up to? 10 raised to 14. How? Let me explain. See, this N square is the square of cars. So here cars given us of 10 raised to 6. So in worst case, for each and every mechanic, 10 raised to 6 can be applied on each and every mechanic. So 10 raised to 6 square is equal to 10 raised to 12. And we are here also we have to multiply rank on each and every mechanic. So in worst case, the time complexity can go up to 10 raised to 12 cross 100 is equal to 10 raised to 14. It is never acceptable because 10 raised to 14 is quite a large time complexity. So we know we can't be solve this problem in O of n. Okay, let us move towards our blackboard. Okay. Okay. Time complexity as we understood, it is 10 raised to 14. How to optimize this? Now, if you have seen my day before yesterday's daily problem, I explained you that whenever there is something like minimum, maximum, maximum of minimum, minimum of maximum, please try binary search. Not try, but just think binary search is the approach of the problem. Okay. If you also don't know this, now as you can see, O of n, it is 10 raised to 14. We can't apply this thing. Then what is the alternate time complexity that we should try? It is obviously n log n. Now for log n, what will you try? Obviously, binary search is the only option to apply right now. So let us think as binary search for optimization. Okay, let us copy this particular screenshot. Okay, so this is the test case given to us. Now for brute force, simply we will be just selecting 1 minute, 2 minute, 3 minutes, 4, 5, dot 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 16, dot 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 up to 10 raised to 14. This is our search space because as I told you, total minutes that we will be finding will be ranging from this to this because cars equal to R cross N square, right? So rank, okay, this is time. So R is of 100 and this is of 10 raised to 6 of square. So it is obviously 10 raised to 14. So first we will be starting for 1, we will be checking, not possible, then 2, then 3, then 4, dot 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 for each and every value for 10 raised to 14. This is our linear, or we can say brute force. But what if we want some optimization? I have given this test case and 1, 2, 3, 4, dot 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 15, 16, 17, dot 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 and 10 raised to 14. This is our search space. Okay. Let me tell you, I give you some random value here. Let us say X. And using X, you have to find out that how many cars mechanic can fix. So time was equal to rank cross n square. I have given you this X as a time. So X equal to R cross n square. So n is the number of cars that each mechanic can fix using X minutes. So n can be denoted as square root of X by R. I hope I am making some sense. So calculate this n for each value of the array like this. And at last, we will be having some n total. Let us name is as n tot. If this is greater than or equal to cars, means this value, it means that given this time x, I can definitely fix this total number of cars, as well as I am also able to fix extra number of cars which is not given to me right now. It means that x can be my probable answer, but I should have to search in this amount of space because it is already greater than equal to cars and we have to return the minimum. So if x is fulfilling my condition, then there definitely there will be some value less than x in this part which will be satisfying my value. So we will be nothing, just we will be pushing our high pointer to mid minus low, or we can say x minus 1 in this case. So can you think this is a binary search because we are eliminating this search space here? Because I know x is my answer, so values greater than x, they might be or might not be answer, but my most optimal answer will be lying somewhere here only. So this is the main observation to apply binary search. Now, okay, let us assume that this is the search space 1 to dot 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 16 as to 10 raised to 14, and x is value somewhere here. Okay, and now here using this x, the whatever n total we have obtained, it is less than total cars. It means the time x that I was allotting to each mechanic, it is not sufficient for that mechanic to repair cars or total cars of 10. It means, so in this case, if x was not sufficient for me, I have to obviously search for the values which are larger than x to find my probable potential answer, which is most optimized one. So using binary search, we are eliminating some search spaces either on left hand side or on right hand side, and potentially we are able to find most optimal answer in optimal time complexity. Okay, what will be the time complexity in binary search? It will log of 10 raised to 14 cross ranks. It will log of 10 raised to 14 cross 100 in worst case. So the most dangerous part, okay, okay, 10 raised to 12. The most dangerous part, which was our main hindrance in time complexity, we have just applied logarithmic function in this. So this is the best approach we can use. So let us directly move towards understanding of the code. This is the code. Here answer I have written int max because we are supposed to find minimum. So function with which we will be doing minimum, it should be greatest in value. Low equal to 1 because as I told you, our search space is from 1 to 10 raised to 14. Now, while low less than equal to high, the main condition for binary search, we are calculating mid, and please don't forget to apply long here because long is here. So probably there might be some overflow in the value, which we are not willing. So please make sure that prevention is better than cure. So yes, and for corresponding mid value, we will be calculating how many cars that mechanic is able to. So see, mid by V of I was n square, and for n square root we applied. So n was the number of cars that given mechanic can repair. So if count is greater than equal to cars, it means that mechanic was able to fix, or total n tot that we have understood in the question is greater than the cars. So we will be just breaking from here. It means the value of mid that we have calculated, the time is obviously some greater value. So we have to find in some lesser search space than initially we were. So okay, this might be my probable answer because mid, because here Mechanics were able to fix cars which is greater than our car's value which we are supposed to find. So this might be my probable answer, and we will be just searching in the left space because we are searching for some smaller value. And if this count is less than equal to cars, it means the time allotted to each mechanic was not sufficient enough to fix all the cars. Then we have to search for some higher value. So we'll be doing just low equal to mid plus 1, and at last we will be just returning the answer. Okay, this code I already submitted, but let us submit it again. And 91%, as you can see, because this is the most optimal approach. And yes, I think it's enough from my side for this problem. Please give this problem a try because it is relatively an easier question. Binary search is the standard approach of this question. Please give this problem a try. Till then, keep learning, keep learning. We will be meeting in the next video. Thank you very much.